the two things we want to do today, I want to show you how to solve matrices on your TI-84s. Okay, and then that won't take long, and then we're going to jump into some application problems and get a little practice with those. So let's start off with something like this, right? So how would we do this, solve this 3x3 system with technology with the TI-84? So here's what you do. Okay, and I'm going to, how do I clear? Let me try something here. Catalog. Alpha C. Oops, that's not what I want. Quit. Catalog. Oh, why is it doing that?
You don't have to wait.
I don't know what it's doing. You're supposed to be able to go catalog. Maybe I just hit C. Yeah, there we go. Okay. Clear.
So he said,
Huh. Try clear entries. Okay. Well, you don't have to do any of this stuff. This isn't important. I was just trying to get something reset for you guys. Ah, it doesn't do it. I don't know how to clear a matrix. Not sure how to do that. Can I hit delete?
Do you have to go over to that and then click delete?
No, I don't even know what this is. Edit. Matrix 1. I guess maybe I just do 0 by 0 or something. No, I can't do that either. I don't know. Okay, so the moral of the story is, hey, listen, please. So we're gonna do some matrix stuff, and I don't know how to clear, but you don't ever have to. It's not a big deal. So we want to build a matrix. Here's how you do this stuff. You have to go to the matrix screen, which is right there, right? So I hit second matrix, and then there are three different columns, three different menus. The names menu, which is how you retrieve matrices to do stuff with them. We're not there yet. We have to build it first. There's the math menu, which is where we can do all kinds of matrix math with our matrix, okay? And then there's the edit menu, which is what we need. The edit menu is what's going to build the matrix that we're going to use to solve this problem. So we want to go to the edit menu and either hit enter or 1 to pick up that first matrix, okay? So what do we want the dimensions to be? The dimensions of a matrix always go rows first by columns second. So there are 3 rows, so it needs to be 3 by 4. So I'd hit 3, enter, 4, enter, and you're going to see a blank template open up, right? Everybody get that? Okay. So then now you're just going to go through and build these rows like you normally would. They're in standard form. So what would the first row be? 1, 1, keep going, 3, 12. There's row 1. And on the calculators, you just hit enter every time. And it knows to go to the right, and then it goes down to the next row and starts over. So just always hit enter. So the next one would be -3, enter, 7, enter, etc. Just keep going. So there's my matrix. Agreed? Everybody get the same thing? Yeah, so to get there, you just go, here, let me quit this. So to get there, you go second, hit that button right there with has a matrix, right? That's the one we want. That's why we hit second, so it goes to the function behind the key. So second matrix, and then we scoot over to the edit menu and hit either 1 or enter to get to our matrix. And then we have to just build the matrix corresponding to our linear system. Okay?
My screen's a little goofy, but it won't count.
Okay, so everybody got that? Okay, so once you're done, then this is important. You have to quit. So you hit second, quit. So we're out of that matrix. And now I'll just show you a couple things. If I want to pull up matrix A, I can go to second matrix. And in the names column, I just hit enter or 1. And that means matrix A, right? So if I hit enter, look what it does. It gives me back, it outputs that matrix. Okay? All right. Now that's not what we want to do, though. We want to do, isn't that cool? So we want to do RREF. We want to put that matrix in reduced row echelon form, just like we did with Desmos. Okay? Everybody with me? Okay. So then we're going to go second matrix, and we're going to scoot over to the math menu. And we want to go clear down the menu, but instead of going down really far, let's just loop up from the bottom and hit the up arrow and go up to row B, which is RREF, just like in Desmos. So I choose that one. And what goes inside RREF, do you think? A, exactly. So I've got to go second matrix 1, close the parentheses, and hit enter. And look at that. That looks familiar, doesn't it? Okay. Right. So notice what that is. There's the output, right? Okay, did anybody get something different? Okay, if you got something different, then it means you started off, you made some little mistake when you wrote your matrix down, when you wrote down the system as a matrix. So this is, now notice what we get here. If we look at just the first square part of the matrix, so it's 3 rows, that means we look at the first 3 columns. Notice it's the identity matrix, right? So we're getting 1, 1, 1, and everything else is zeros, right? Bottom or top left to bottom right are ones, everything else is zeros. And so this is just telling us, isn't it, that x equals 5, y equals -2, z equals 3, right? Everybody agree? Okay. So now let's try one of these. How about, like, try that one? Yeah, just real quickly, crank that out. Get a little practice. Put that in your calculators and crank that out. Oops.
We all know. Yeah. You did the same one.
It is no solution. So you got to quit. Second matrix, math, RREF, A. Oops, darn it. So everybody got that? Okay. Okay, so what's that mean, right? How do we interpret this? So yeah, so we don't get, if we look at the first square part of the matrix, it's not normal. It's not the identity matrix. So we know it's not a single solution, right? So where do we always go? Bottom row. We go to the bottom row. The bottom row says 0 equals 1, which is false. So this is a no solution. Okay, try one more. Quickly. Try that one right there. Try that guy.
Oh, up there. Oh, I didn't see that. I don't remember what he did.
You literally just forgot.
I'm not sure about it. Oh my goodness. I got something weird.
Whoa. What the?
Yeah. Okay. Did you get?
Lots of them.
Did you get decimal?
Yes, you did. Okay, but I want to show you a trick. So everybody probably got this, right? You got that. Okay. That's a mess. Now you might recognize that decimal to be 1/7. Hopefully you do. If you don't, that's okay. I can show you how to make it a 1/7. There isn't a nice little convenient button on here like there is on Desmos, but you can go to, on your TI-84s, you just go math, and the first option is convert to fraction. It gives you that little arrow, which means turn it into a fraction. So we'll just either hit 1 or enter, and it's going to take your answer, convert it to fractions. So hit enter again. Look what it does. Okay, how about that, right? Okay, so then this is what we get. Okay, so just a review from yesterday. Think what that means. That first row means 1x plus 1/7 z equals 0, right? If I solve that for x, I get x equals negative 1/7 z. Second row says 1y minus 1/7 z equals 0. Solve for y, I get y equals positive 1/7 z. So how would I write that as an ordered pair? Because you're going to get some problems like this on the assignment. This is how you would write it. Because each of these x and y are both being compared to z. Everybody see that? Z is the thing that's common there, right? Not x or y. There's only an x term in the first equation and only a y term in the second equation, but there are z terms in both. So z is kind of the common denominator there. Not really, right? But it's what's common to both of those equations. So we want to write the answers in terms of z. So I'm just going to take this first equation and substitute for x, negative 1/7 z. I'm going to substitute for y, positive 1/7 z. And I'm going to leave the z coordinate as z. How come? Because z could be anything, right? There are an infinite number of solutions here, and they're all based on z. So I want to write my ordered pair, my ordered triple, not an ordered pair, sorry, my ordered triple. So the z coordinate is simply just the variable z, which could be anything, right? If z equals 7, then the value of the x coordinate would be negative 1/7 times 7, which is negative 1. The value of the y coordinate would be positive 1, and z would be 7, right? So what does that correspond to? That's just a point in three-dimensional space, right? I go over 1 to the right, or over 1 to the left, up 1 and out of the board 7, right? If I plug in negative 7 for z, I would get the coordinates positive 1, negative 1, negative 7. What does that mean? 1 to the right, 1 down, behind the board 7. Okay? If I plug in 14, negative 2, 2, 14. If I connected all those infinite points, With a line, I'm just going to get some line that's coming out of the board, right? And it's going to be, it's not just coming straight out of the board. It's kind of traveling through all three. Well, how do I say this? It's got an intercept in all three different planes: XZ plane, YZ plane, XY plane, right? Make sense? So we don't need to, how do you write the equation of that line? We don't have to do that for now. All you need to do is just show that this is the relationship. That's how you would write your answer in Math Excel for School. Okay? Make sense? Okay. You'll see a couple like that. All right, moving on.
Are we able to use the calculator on the test for these?
Yes, you will. You will. There's going to be, so on the test, there's going to be two parts. There's going to be, this will be actually two tests in one. There's going to be a non-graphing utility test where you can't have access to Desmos graphing or the TI-84. So you're going to, on that one, you're going to solve regular systems and all the other stuff we do this unit. But you're going to have to solve a 3x3 system algebraically. But you only have to do like one, probably one of those on the test. Yeah, you can use Desmos Scientific, absolutely. Yeah, that's fine. But that's not going to help you much in terms of, you're still going to have to do all the, you're going to have to use elimination, right, to solve it. Right. But then there'll be a second part of the test, which will be a graphing utility test, where I will give you access to Desmos, or you can use your Desmos graphing, or you can use your TI-84. And I'll also give you access to the Desmos matrix calculator. Okay. And on that one, that's going to be the stuff where you're going to do regression lines. You're going to solve big systems, probably a 4x4 system using matrices on any technology you want. I don't care. And then also, it'd be stuff like this kind of stuff. The applications of linear systems, I will put that on the graphing utility part of the test, so you can use the graphing utility to quickly get answers. Okay. So what we want to focus on now is how can we set up, we've got this application, how can we set up a linear system and then solve it the most convenient way using matrices. Okay. So what about this one? The theater sells 3 types of tickets: general admission, senior citizen, and child. Mark bought 9 general admission tickets, 2 senior citizen tickets, and 3 child tickets and paid $170. Okay. It gives us another combination of different tickets options that cost $173, a third combination that costs $116.50. And it says find the cost of each type of ticket, right? So then what are the variables going to represent here? Okay, well, what about them? Is it the number of tickets or the price of tickets? What's it going to be? It's not a hard question. I'm not trying to trick you. What is? I mean, you look at the last sentence, the question. We're finding the cost, aren't we? Right? Okay. So the variables then are just going to be x equals. We'll just call it general admission cost. I'm just going to call it GA cost. Y equals senior cost. Z equals child cost. So there's our variables, right? Now the issue is, can we come up, we've got 3 variables or 3 unknowns. How many equations must we have in our system? 3, a minimum of 3, right? So we need 3. Can we come up with those? Well, let's see. How about this first one? It tells us that Mark bought 9 general, 2 senior, and 1 child tickets and paid $170.
About 3 children? Why would you buy 3 children?
3 children tickets, yeah, child tickets. How's that going to be? What do you think?
9x plus 2y plus 3z equals 170.
That's right. Okay, but now does everybody see why? Isn't 9x, doesn't that represent the cost of all of the general admission tickets? if they're X dollars a piece and we're buying 9 of them, well, yeah, 9X is how much we're paying for general admission, et cetera, that, right? So this is going to be a pretty straightforward one, isn't it? We're going to have these 3 different permutations. Each of them gives us an equation, right? The next one would just be what? 5X plus 4Y plus 7Z equals 173. And then finally, last one, 4X plus Y plus 6Z equals 11650, right? Okay, right? And so that's what you get, right? There's what you get. If you do all that stuff,
I don't think you can drag it.
I can't. What's going on? I should be able to drag that though. Why can't I? This is so weird. Why can I not do this?
So many ways. Oh my goodness.
There we go. Okay, everybody agree? That's what you get if I build that system. So those are my answers. What's that tell me? It tells me the cost of a general is $13.50, senior citizen ticket is $11.50, child ticket is $8.50, right?
Children are expensive.
Okay, so try this guy. Yeah. He's got lots of change.
You don't collect change?
I don't keep change. All of my change on me. I keep it all in a jar.
Okay. Aurora. Okay, so let's take a look up here. What are our variables going to be? Okay, what do they represent?
Nickels, dimes, and quarters.
Okay, and you say nickels, dimes, and quarters. Talk about numbers of each, right?
Yes.
Okay. So we've got X. Oh man, it did this again. Oh my goodness, this drives me nuts. I don't know why it does this, but I gotta. Here, I'll leave this up here for a second so you guys think about this while I'm rebooting this. Hey, you guys, don't get sidetracked on dumb stuff. This is you got your attention should be 100% on this right now. If it's not, you're making a mistake. Okay, so what are we going to do? So we've got our variables, right? So we need 3 equations. Okay. Well, where's the first equation coming from? Okay, total number. Yeah. So it's this right here. Okay. So what's that going to be, Jake? What's that equation then?
78. Well, it would be X plus Y plus Z.
There you go. X plus Y plus Z equals 78.
Because you're counting points first.
All right. So typically with problems like this, if it's giving you the total number, usually the variables represent the number of each kind of thing, right? Almost always. Not always, but most times. So the total number of all the different options is usually going to be one of the equations. X plus Y plus Z is the total number of coins, which is 78. Okay, there's one. Let's get another one. What other information is going to give me another equation? Let's at least say that. What do you think? Okay, so we could do that one. So let's do if the number of quarters is double. I'll tell you what, let's not do that one next because, yeah, let's do that one third because it's so similar to the second one. What? Okay, so this is we got to get an equation out of that, but it's not just X plus Y plus Z because that just gives us the total number of quarters. We want the total value of the coins to equal 1240. What's the value of all the nickels?
And then you multiply them all by 100 and get 5, 10, 25.
Okay, but you don't, now if you're using technology, you don't have to multiply everything by 100. You just leave it like that because the technology is going to solve it either way. It doesn't make any difference, right? Just leave it like that. What's the last equation going to be, though? If the number of quarters is doubled, the value becomes 2215.
So wouldn't it be like,
So,
You leave X and Y alone.
so the value of the nickels is going to stay the same, right?
Yes.
The value of the dimes stays the same. Okay, but instead of multiplying 0.25 times z, we're going to multiply it times 2z. There you go. So we could take that last equation and we want to simplify that a little bit, don't we? We want to 2 times 0.25. We'll just replace it with this. Agreed? Okay. And if we do that, this is, so here's our matrix that we use. Right there. That's the matrix we just built, isn't it? Agreed? Isn't that what that's because we're getting rid of that row and replacing it with that one.
Yes.
Right? So if I do RREF, there's my answer. So what's that tell me? So what is X? 25 nickels, 14 dimes, 39 quarters. There you go. Okay. Okay, how about this one? Yes. Okay. Okay, so this one, it is. Yeah. Yeah, that's here. Let's get rid of that. That's just going to confuse people. That's just going to confuse people. It may not be right.
What do you mean? No.
It may not be right. Never know. Okay, focus. See, what do you get there? Think about it. What do you get? What do you get? Okay. Okay, so I'm going to let you guys think about this for a second. Let's figure out what the variables are and type that in, first of all. So you got to read the question probably twice because this is kind of a tricky question. It's asking for how many gallons of each grade of water should she use? Well, yeah, look, she's using 3 grades of water. One of them, the expensive grade, is $9 per gallon. The cheapo grade is $2 per gallon. The medium grade is $4.50 per gallon. Okay, so let's define our variables here. I'm going to do you a favor, and I'm going to type this instead of writing it. How about? So X is going to equal gallons of expensive. Okay. Okay. Gallon of expensive H2O. Y equals gallons of cheapo water. Z equals there we go. Okay, we good? So now we got to come up with some equations here. Okay, what are we going to get here? We got to come up with some equations. So can anybody see an equation popping out?
X equals gallons.
Oh.
We need 200 gallons of water.
Yep. Oh, okay. So. I agree with that.
So what's that give us then? Does anybody? Hey, quiet. If you raise your hand if you have something to say. There you go. Okay, he's our total volume specialist right here. So that we get the same equation. X plus Y plus Z equals 200. Okay, the total number of gallons is 200. Okay, now it gets a little bit trickier, right? She wants. Here's another. I'll give you a hint. Here's where the other equation has to come from. She wants to sell this for $5 per gallon, right? $5 per gallon. She wants the mixture to sell for $5 per gallon. What do you think?
Yes. She wishes to mix 3 grades of water.
Yeah.
Would that make sense?
Okay, so here's the hint I'll give you, right? So if she wants this to sell for $5 per gallon, then how much should all of the water cost total?
Oh.
200 times 5. Everybody see that? Okay, so that's kind of key. So on this one, the next equation is going to be about what is the value of each grade of water if the total value of all the water is going to be 200 gallons at $5 per gallon is going to be 1,000, right? So what is the value of the expensive water? Well, isn't that just 9x,
Yes.
right? $9 per gallon times X gallons. The value of the cheapo water is 2y, and the value of the mid-grade water is 4.5z, right?
Equals 1,000.
And that all equals 1,000, which is actually coming from 5 times 200, right? Okay, good. Hey, listen. There's this. This class I love this class, but man, you guys can drive me nuts sometimes because there's so much like little chit chat going on. It's got to be. If it distracts me, it's got to be distracting other people, right? So just don't do that. We got to focus. This is focus time. So last one. How many gallons of each should she use if? What else did she say? She must use twice as much of the 450 water as the $2 water. So how are you going to say that as an equation? Okay, you're close.
Would you leave X and Y?
You'd need X and Y, exactly. No, sorry, Y and Z, I think, right? Okay, what's another way of saying that? Can you rephrase that in a way that's kinder to the math? That's going to equate to, or it's going to, I'm going to be able to translate it to an equation more easily. Instead of saying she must use twice as much of the 450 water as the $2 water, doesn't that just mean that the gallons of mid-grade water equal twice the number of gallons of cheap water? Everybody agree? So if I say it that way, doesn't it then mean that Z equals 2y, right? The amount of mid-grade equals twice the amount of cheapo, right? Okay, so now this is it. This is our system, but it doesn't look like the right kind of system. Those equations aren't written in standard form, right? The first two are, but what do I have to do to the third one? Yeah, I've got to move either the Z to this side or the 2y to that side. It doesn't matter. Take your pick. Either way is fine. So the first equation is good. X plus y plus z equals 200. Second equation is great. 9x plus 2y plus 4.5z equals 1,000. But this one, what if I subtract the 2y over to this side? That's going to give me 0x minus 2y plus z equals 0, right? Okay, now that looks good. Now I've got it in, all those are in standard form. So I should be able to turn that into a 3x3 linear system in a matrix and come up with the answer, right? If you do that, we're going to run out of time here. That's what you get. So you can try this one, just see if you get it. Everybody get 50, 50, and 100?
I got that.
Good. There you go. So that's the answer. Okay. All right.
I don't know how we got there, but we did.